Hi, I'm Vince Weaver. I'm a professor at the University of Maine, and I'm here today to talk to you about Myst Demake for the Apple II computers. First, you might be asking, Maine, is there any connection to Apple II from Maine? And it turns out we do have one. Chuck Peddle, who led the design of the 6502 processor, actually lived in Maine and attended the University of Maine a long time ago, and we managed to convince him to come visit not long before his death. But here I am with him and showing off a Commodore PET Mini that we had someone in Spain make and sent, and he really liked that. We also set up a display for the students to see if so they could experience 6502 processors, and not many had, obviously. And we had some Apple IIs and some other things set up during this, so that was sort of fun. Um, but I'm here today to talk about demakes. So if you're not familiar with the concept of a demake is when you take a modern game and try to make it run on retro hardware. And why do that? It's fun. There's a challenge to it, so it's a thing I like to do. And I've done a number of demakes. So one I've done is Another World for the Apple II, which you can see there. I've also made Kerbal Space Program and Portal, and that's the Is It Cake is a Lie Portal, not the older Portal version, Portal program you can get for the Apple II. And those are all playable. The latter two are written in AppleSoft Basic, and so they're sort of limited, but you can get those. I also do some other things. I do a lot of demo scene programming, so I like doing demos that involve a lot of cycle counting and vapor lock and exciting things like changing resolutions mid-scan line and all that to do some pretty impressive graphics, so I've done that. And I also like getting chiptune music, kind of stuff you normally hear on like a ZX Spectrum or an Atari system, to play on the Mockingbird card you can get for your Apple II, because they all use the same sound chip. So I've learned all that stuff. Sometimes people are surprised to find out that all these different projects were actually me and not like a whole team of people. But today I'll talk a little bit more about the demakes. So today we'll talk about Myst. So Myst was a game from the early 90s, around 1993. Cyan Inc. with the Miller brothers, they wrote this. It was originally for the Mac with 256 colors, and it was programmed in HyperCard. It was a very early CD-ROM game. It's actually considered one of the things that popularized CD-ROMs. And it's fairly big, 550 megabytes. And 6 million copies sold. You might say, did all those people beat the game? And the answer is probably not. It was considered a very hard game, and a lot of people had sort of a love-hate relationship with the game. And it was a point-and-click game with pre-rendered graphics. So unlike modern games, it didn't you didn't have the GPU generating the graphics on the fly, but they all pre-rendered in advance and then loaded off the CD-ROM. And I played the game soon after it came out, probably in '94 or so. A friend of mine got it for Christmas, and so I went to his house every weekend for a few months to beat the game. And it was a bit of a challenge. There's an infamous puzzle where you sort of need perfect pitch to play a piano to solve a puzzle. And also, ours, one of the early versions of the game, there was actually a bug in one of the clues that told you to do the wrong thing. And this was before, the internet was widely available. So the only way we figured this out was we went to Best Buy and found a strategy guide and looked up the solution and found out that, oh yes, we had a buggy version of the game. So, but still, it's a good game. I also wasn't very happy with the ending at the time. The ending's mostly there to set up for the sequel, and so if you played it for a long time, it can be a bit frustrating. So the plot of the game is you find a mysterious book, and it turns out this book was written by people from another dimension, other land. Anyway, they have the power to write books of a special ink that lets you link between worlds. And you find one of these books and accidentally link through it to this island called Myst, and you sort of have to unravel the mystery there by solving puzzles. And you find out a man who lived there, who's trapped, and his sons got into some trouble, and you got to solve the mystery and figure out how to escape, and do this again by walking around, solving puzzles, linking to other worlds with linking books. And so it's a pretty cool concept. So the question, though, is, can you take this 1993 CD-ROM game and fit it on an Apple II from 1977, or I guess more likely 1979, because you probably want to load this off a cassette tape. And so that's what we're going to talk about today. So system requirements. So what would you need to run this? So I've got it working, and you're fine if an Apple II, 2 Plus, or 2E. It should run under 2C or 2GS. I actually just this morning tested on the 2GS, and we had some code, so now it seems to work well. You need a disk 2 drive for putting the disk in, 48K of RAM. If you want the digitized sound effects, you need 64K with a language card, but if you're fine about the sound effects, 48K is enough. And if you want to hear the music in the intro, you'll need a Mockingbird card. So current status, the game's fully playable from the intro straight through to the various endings. The main island is more or less complete. Some of the puzzles in the sub-ages and the sub-places you go to are not quite done yet, but the game is still playable, and you can still go around even when the puzzles aren't quite done, and I plan to finish those up soon. Some puzzles, like there's an infamous submarine puzzle in the one age, is considered a bit tedious at the best of times, and so I probably will never get around to implementing that, but all the fun puzzles, they'll be there. So I originally hoped to get the game to fit on one single 140K floppy. That didn't happen, and so it's broken up into 15 different segments of the game, and you can see them there in the map, and each one, the max you can sort of fit is about 40K, so I had to split it up a bit. So it looks like we might have a little bit of time to actually do a quick playthrough a little bit of the game. So here we are in the intro. I'll skip through it a little bit to make it a bit faster, but get to here. Playing some nice Mockingbird theme music here. That was one of the visual sound effects. It sounds a little bit better on real hardware. And then you can just walk around the game. So you just walk around, and you can use the pointer to point where you're going, and look around, touch things, break things. And again, it's a lot like, hopefully, the original game, walking around here. It's very much based on the original game, where you just walked around like this in a very point-and-click fashion. In the later versions of the game, they came out with remakes that were, 3D, fully rendered and all that. So, you can check out, pick up things, see what's in the book, open things, go in secret passages, that kind of stuff. So how was the game designed? So the game engine is actually pretty simple. As we said, it was a fairly simple game originally. It was a hypercard stack type game. So I wrote from scratch by playing the game. I didn't investigate the source code. I didn't reverse engineer everything. I just played the game and figured out ways to re-implement it from scratch. And it's written entirely in 6502 assembly language. So the main game loop, the first thing it does when it goes through the loop is it copies the background from address C00, where we store the background, and then copy it to an off-screen page. So the Apple II supports page flipping, so it has 2 pages of graphics, low-resolution graphics you can use, and one's on being displayed, and you can draw the other one at the same time. So we copy to the off-screen page. We draw in any foreground items or animations. This is sort of optional, but in some rooms you're in, there are animations and all that. After that, it draws the hand cursor you're using for touching things, and some sort of special cases on the edge of the screen, or if you're holding things, they might change what the cursor looks like. Once it's all drawn, it then flips to the screen, and by waiting until after you draw things to flip the graphics page instantly, it's one of the nice features the Apple II has. You can avoid any sort of artifacts or tearing and stuff you get if you're drawing while you're viewing the screen. After that, we check the keyboard and then move the cursor. And if you click on something, the location of the background, the action happens. And if you go to a new level, then it exits out to the loader, and then from disk, the next place you want to go is loaded. So some common helper routines to help with all this. There's one that decompresses the backgrounds from memory using LZSA format to the address C00. And then there's a fast memory copy that will copy that to page 1 or page 2. And we have some fast low-res sprite drawing code. It has some cheats to make it faster, so your Y coordinate has to be even, and that's done to make the code much simpler, because if it's not, you have to have all kinds of shifting and masking and stuff to do things. It also handles transparency, so The Apple II in low res mode, there are two colors that are gray, 5 and 10, and they're both supposed to be similar. It's sort of complicated. But we don't need the two grays, so we use the second one as a transparency color, and that way we can get all 15 colors, including black, in your sprites, and then have the extra color used for the transparency. One other thing that we do is that on the Apple II, text and low-res graphics are actually drawn in the same page with the same sort of code. So in a lot of cases, we'll actually treat the text we're drawing just as if we were drawing or loading graphics from the screen. So the way the game's actually implemented is a series of interconnected rooms, and here's the data structure, example data structure from one of the rooms showing how it's set up. So what happens for each one of these, you have 4 exits, north, south, east, and west, and you have those point to the next room if you go in that direction where you go. Also the 4 exit directions, because when you leave a room you might turn around or it might turn you in different directions, so you have those. Then 4 spots for backgrounds, so you can have the 4 background images around you. You don't have them all filled in, but when you're pointing in that direction, that's what you'll see. And the one last thing you have is a special exit, which is actually on the screen there'll be some X and Y coordinates, and the idea is if you touch the cursor in those X and Y coordinates, it will call a special routine, and that's how you handle picking up things and touching things and having puzzles and all that. And you'll notice it has that callback with a -1 on the end, and the reason we do that is because we're not just jumping to this for various reasons, including there's a 6502 bug you can trigger. We actually jump to this helper routine with a RTS, a return call, rather than a direct jump call. So there's some complex puzzles that do some interesting stuff, most notably some mixed text and graphics. So the generator puzzle, it actually has some ASCII code numbers and dials made of ASCII codes. And to sort of hide that, we use some inverse spaces to make it look like it's part of the graphics. There's a planetarium room where you look for the stars, and there's some complicated stuff. It also shows some text down below, and so we have some mixed mode for that. There's some complicated things. So some rooms have more than 4 exits. Most notably, the library is actually in the shape of an octagon, and you have the handle going all 8 directions. And so we do some special stuff with the special callbacks to implement that. Input issues. So input in the Apple II is always a challenge, especially the keyboard. So there's no up or down keys on an Apple II Plus. So to do that, we also handle the arrow keys, but we also use the WASD keys for movement. Another thing is you can't tell how long keys being held down on an Apple II. So for puzzles that depend on how long you hold things, for example, in the Lighthouse, there's a puzzle where you pull down a lever and hold it for a while, and you can't really do that in the Apple II. There's no way to know how long you had the key down. So we had to mess around with the way the puzzle is done to make it so you can still do the puzzle. Joystick, I would like that joystick support. I actually planned on doing it, but just ran out of time before Kansasfest. It does add some latency for reading the joystick, so I'm not sure how that will affect things, but I do plan to do that. Mouse, you can get mouse for Apple II, and this game originally had a mouse. I don't have one though, so it's less likely that mouse support will get added. So graphics images, so we have all those rooms, and you can fit maybe about 40 rooms in the 40K before you sort of run out of space. And so they all have background images, and currently have 729 background images, and all those I've hand-drawn or traced over from the actual original graphics. So it was a lot of work. It took a lot of time to do that. Here's some examples. So designing the graphics, what happens, I get a screenshot from the game. The way I do it, I have ScumVM and I have the Steam version of Myst, and I go and grab the screens I want to do, and then I load them into the GIMP, and then I trace over them with the colors and then convert to the Apple II palette, and I have some tools to convert them. If you're interested in that process, there's a YouTube video linked here that you can go to, and it has a whole step-by-step process showing how I do that. So the most common question I get asked about this game is why not use better graphics? Why low res? Why don't you use something better, like high res or double high res or double low res and all that? So there's a few reasons for that. I like low res graphics, and I have a lot of existing code for loading them, animating them, using sprites and all them. Another big one is I want to run this on an Apple II Plus I have, and so the newer graphics modes won't work on an Apple II Plus. And another big one is trying to fit this all in RAM so you can run, avoid having to leave it to go to disk and things like that. It turns out that going to disk is very slow, and in the middle of the game, if you every 3 steps you had to wait for it to load off a disk, that's sort of a pain. Or better than a Commodore 64, where it might take hours to do. Will feel like hours to do that. But the Disk 2 drive, even when I'm using Cucumba's optimized routines, still takes a little bit of time to load things from disk. So I ran some examples to show off, what things might look like if we could use the other graphics modes. And I've taken these all screenshots of Apple Win, and I'm using Bill Buckle's BMP to DHR utility using Floyd Steinberg dithering to generate the images. There's a lot of options for this. And I have some super high-res images, and I use GS Plus and Super Converter to get those results. So first of all, low res, if you automatically run this through a tool to get it, what do you get? And you can see that it's actually a little hard to see. And this is trouble playing a game like this. You want to be able to know where the puzzles are, where you can walk, what materials things are made out of, maybe consistent colors of the sky and all that. And it doesn't look too bad on this small thing, but on a full-size screen, this is sort of grainy graphics. So for comparison, here's the hand-drawn stuff I did. And so, things are a bit different. The sea is a solid color. You can tell where to go. The puzzles are there. Just getting things consistently, like to pick a consistent sky color and a consistent ocean color was actually a bit of a challenge in getting things to work out. You can see I had to use the aqua color, which is always, I feel like, a horrible color in the Apple II, but it works out. On the right, you'll see that I struggled a bit in a selenitic age. That age has got a lot of grays and blues and rocks and stuff like that. It was really hard to get consistent colors where you didn't have the same color next to each other, and that was much more of a challenge. The other ages weren't quite so bad. So instead, if you want to use double low res, so that resolution is 80 by 48, it's twice as many horizontal pixels. It takes twice as much space too, 2 kilobytes instead of 1 kilobytes per image. And you really need an Apple IIe or 80 column card and some really complicated code to get it. Those screenshots down there, it took me a very long time to manage to get those images into this emulator so I could take the screenshots. It's a complicated mode to use, especially if you're trying to do page flipping. So the high-res mode, which is 280 by 192, or it's more accurately, it's 140 by 192 with 6 colors. It looks a lot better, but again, it takes 8 kilobytes for these. If you want to do page flipping, that'd be 16 kilobytes. If we only have 48 kilobytes of RAM, that's 130 RAM out the window just for the graphics. And so there also graphics will be on average maybe about 8 times bigger than the other one. So you can see you'd have a lot more trouble fitting in on a reasonable number of disks or on a reasonable amount of RAM. Double high res looks even better. This is the same resolution as last time, but with 15 colors instead of 6. But again, it's twice as big as before. You really have to have 128K Apple IIe to use it. The code for this is even more complicated. And finally, super high res. So this is on the Apple II GS, and you can see the graphics almost look as good as the original graphics. And this makes sense because the 2GS was almost contemporary with some systems that saw real ports of Myst, like the Amiga. It was a much more recent system and almost was around still being developed for at the time that Myst came out. So in the end, I stuck with my low-res graphics, and part of this was trying to limit the number of 140K floppies you needed. As I said, I originally tried to fit in 1 and then 2, maybe both sides of 1, but then it got to 3. And so how do we fit? One thing you do is compression, compress things so they fit better. One is using the low-res images that we do. Having fewer areas of the game. So in the game, there's actually a lot more than you can actually walk through in the game as designed. In general, every other step along the way I've skipped, and you really don't miss much by missing every other step. I also simplify some corner cases. So some things like in Channelwood, there are these pentagon platforms through the swamp, and you can look at various, maybe up to 6 ways, and it gets really complicated. And it's really hard to navigate in the real game, and so by limiting things in the Demake, it hasn't really made it that much worse. So, as I said, it's really good to try to fit into RAM because swapping floppies and waiting for things to load just takes you out of the game. So could we get even smaller? So one thing you could do would be simpler graphics that compress better, so even more cartoony than I have, but I tried some of that and you sort of lose something. Another would be to generate the background sort of algorithmically. So for example, there's like a pillars area, these pillars and buttons you press, and the backgrounds in the far background doesn't really matter. You can maybe just have a generic ocean or forest background and build scenes that way, but in the end it was too much trouble to do that. Some paths in the game are mirror images of each other, and so we could possibly have a flag and automatically flip and then save some images, but again, it didn't seem like it'd save enough room to be worth doing that. There's some crazy disk hacks you can do, so like a custom bootloader. I actually throw DOS away in memory and use Cucumber's routines, and I could just replace everything and write my own custom bootloader and all that. Or alternately, you can use the RWTS 18 disk format, which fits 160K on a disk by doing some crazy rewriting how the disks are written. But again, things fit reasonably on 3 disks. It's probably not worth the trouble for that. So compression, to compress things, we used the LZSA2 compression library by Emmanuel Marti, and Cucumber had some part in the 6502 version of this code. And this makes a very nice difference. The graphics compressed down to about a third of the original size. So that graph down that you're seeing, that's a plot for every image in the game broken out by the various places they're in. So top of the graph is 1024 bytes. That's how big it would be uncompressed. And then you can see the compressed size is almost always about half the size, and in many cases much smaller, and so we average out to about a third of the size. And so that's how we can take, roughly 800 kilobytes of graphics and fit them on 340K disks with this amazing compression stuff. Other things, disk I/O and loading and saving games. So as I said, the levels are split up in the max size about 40K. And we use the DOS 3.3 file system, but we're not using DOS 3.3. That takes up a big chunk of your RAM. I'm using the RTS by Cucumber to do the loading. He was nice enough when I was trying to get save games to work to write some save code, and he sent it to me, and I just haven't had time to try it out again. Ran out of time for Kansasfest. Loading and save games is fairly straightforward because the game state is not very big. It's only about 74 bytes in the 0 page, and so you just load and store that, and you can have load and save games. So you can load currently for debugging purposes. Saving is definitely possible, but just ran out of time on it. One other thing that's important in Myst is sound. Myst is a very atmospheric game. There's a lot of sound and music and sound cues through it and puzzles involving sound. And so it's hard to have the game without having sound, but the Apple II struggles a bit with sound. And for simple things like clicks or tones, we can just use the speaker. Digital sounds are trickier. They take up a lot more room, and we try to do that by using the language card. So currently the one sound I have implemented is the linking book noise when you go through the linking book, and it takes up 12K. There's still a 4K spot in the language card, and the original plan is to have in the red book the one brother saying, "Bring red pages" noise, but that was 5K, and I was working on shrinking it down. I didn't get it moved back in yet. But in theory, you can rotate sounds in and out for some ages, like the Selenetic age, that has a lot of sound puzzles. To play the digital sound, I use the BTC player by Oliver Schmidt, and which works well. And if you have a Mockingbird, at the intro, as you heard, it plays the PT3 rendition of the Myst theme. And, that's actually fairly small. PT3 files are fairly small. So if I had a lot more time, I could do a lot more of the music. So development, in case you wonder how I develop this, I develop it all in Linux. The graphics I do in the GIMP with some custom tools. I use the CA65 assembler from the CC65 project. I just use the Nano text editor. And testing, I run under Apple II under Wine on Linux. I have scripts that build all the stuff, put it in a disk image, and then I can use it for testing. So future work, things that could be done in the future. It'd be nice to hook up the rest of the puzzles, especially Stone Ship Age. I got all the graphics done. I just have to go back and hook up the puzzles again. Hope to do it for Kansasfest. Ran out of time. Some missing locations, especially Channelwood. Channelwood, this age is very big, and you can wander around in the trees and in the swamp and everything like that. And in the end, I just implemented the part critical to beating the level. I left out a whole bunch of areas you could roam around and poke around in, and it might be interesting to add that back in. Though drawing the graphics for that level is very tedious, so it might be a while before I get around to that. Animations, the game is full of animations. Some of them, like elevators going up and down and things rotating, I have some of them in, but not all of them, so you could add more of that. And as I said, you could add some more sound and some more music. So that's all. If you have any questions, you can email me, or I'll be on the Discord. Feel free to contact me there. There's a web page that's got more info on it and disk images if you want to download it and try it. And there's some source codes, also all the source codes available in my GitHub tree, so feel free to go find it there and try it out. Find bugs, let me know if you find bugs, and thanks for listening to my talk.